Hi everyone. In this video I'll be showing you 10 different metamorphic rock specimens, both foliated and non-foliated specimens, and I'll be describing these specimens in part. Along with the images you'll see of the different specimens, you'll get partial information about each specimen, and from the information that I give you, along with the information in your lab, you'll be expected to identify each specimen in terms of naming it and formally classifying it, and also describing the textures of the various specimens. So this video goes along with one of the lab problems. Okay, let's get started. So this first specimen is M8. It's light colored, and as I turn the specimen around, just notice that we're not really seeing any evidence of mineral alignment. And the other thing about this rock is it's very coarse grained. You can, if I zoom in here, you can see individual crystals. For example, there's a nice crystal right there. This is a type of mineral you're familiar with. It's a non-silicate. In this case, it's a soft mineral that displays really nice rhombohedral cleavage, 3 directions of cleavage that meet at non-90-degree angles. And this is a monomineralic rock, meaning the entire rock is composed of a single mineral, large clusters of the same mineral in this case. And the other big hint about this rock, other than the fact that I'm not seeing any stress-induced alignment of the minerals in the rock, the other big hint about this rock is that the main mineral in the rock, will fizz in weak hydrochloric acid. So that's M8. Here we have M4, and you can see this rock as well is very coarse grained. And the thing that should jump out at you about this rock is that it's visibly banded. We see that the minerals have segregated into light-colored bands that contain mostly feldspar and quartz, along with dark-colored bands that contain various ferromagnesian silicates, especially biotite mica and perhaps hornblende and pyroxene. So this is a coarse-grained rock that clearly displays evidence of stress-induced mineral alignment, and the rock also happens to be banded. Well, on the other end of the spectrum, this is an extremely fine-grained rock. This rock is very fine-grained, M1, and it has sort of a dull appearance. And let's see if I can find a good surface here, especially if we sort of zero in there. Let me do that. You can see this rock is composed of very, very thin layers. So this rock is a product of directed stress as opposed to equally directed pressure. And it tends to split easily into thin sheets. And overall, the rock, as I mentioned, is very fine-grained, and it has sort of a dull appearance. That's M1. M2 is also fine-grained, although not nearly as fine-grained as M1. Let me put M1 and M2 kind of side by side, and I think you can see at a glance that although M2 is pretty fine-grained, it's not as fine-grained as M1. The main difference between M2 and M1 is that M2 displays a little bit of a sheen as opposed to M1, which is quite dull in appearance. And if I turn this rock kind of sideways a little bit, you'll clearly be able to see the stress-induced layering in the rock. So that'll obviously tell you whether this rock is a foliated or a non-foliated rock. And the other big clue about this rock is that although it's fine-grained, in contrast to M1, this rock has a little bit of a dull sheen to it. That's because the minerals in this rock, principally micas, are just large enough where they're starting to reflect a little bit of light, and that's what gives this rock a little bit of a dull sheen. Next we have M3. This is an extremely coarse-grained rock, and if I turn the rock sideways a little bit, I think you'll be able to pretty clearly see the layering in this specimen, the stress-induced layering. This rock has two main minerals. I'm not going to tell you what they are, but I'll describe them, and hopefully you'll be able to figure out what they are. The first mineral is this lighter mineral, and you'll notice it's sort of sparkly a little bit if I move the mineral around in the light. And what we're seeing here is an alignment of mica in this rock. Let me zoom in here a little bit. So this main mineral in the rock, right there, and also right here, is a light colored, that is non-ferromag mica mineral, and hopefully by now you know what that mineral is. It gives the rock an overall kind of light color, and the mica minerals in this case are sort of laid in like shingles or fish scales, and that's what gives the rock this sort of layered appearance. The other main mineral in the rock is this one right here. Let me try to zoom in on that a little bit. This also is a mineral that you're familiar with. It's when you break it open, it's a little bit glassy on the inside. It doesn't have good cleavage. It's sort of a reddish brown, and this mineral tends to be kind of equidimensional, roughly the same diameter from all perspectives. It's a pretty common metamorphic mineral. It also happens to be a birthstone. So see if you can name the two minerals in this rock. Again, this sort of reddish, glassy mineral, which form the large fragments here and here and here, and then the far more numerous light-colored mica mineral in this rock. The other big clue about this rock is that although it does display stress-induced layering, it doesn't display compositional banding. So this rock is non-banded, although it is medium to coarse grained. And the other big clue about this rock in terms of texture is it has these large sort of glassy reddish grains embedded within a matrix of smaller grains. The mica crystals are actually smaller than these large red crystals. If this were an igneous rock, we would say that these sort of two sizes of mineral in the rock would give it a porphyritic texture. But of course, this is a metamorphic rock, so we can't use that terminology here. But this rock does have a texture that's somewhat analogous to a porphyritic texture in igneous rocks. So hopefully you can name this rock and indicate a couple of different textures in this rock, M3. Okay, here we have M9. This rock is actually similar to M1. Let me put M1 kind of side by side with M9. Zoom out a little bit. The main difference, though, is that M9, in contrast to M1, which, as we said before, does display layering, M9 doesn't display layering. I'm not seeing any stress-induced layering in this rock. Overall, it's dark colored and very fine-grained. It's also kind of dull, similar to M1, but again, it doesn't display stress-induced layering. It's also, as I mentioned, pretty dark colored. So hopefully that'll give you enough information to classify this rock and make some inferences about it. Next we have M10. This is an interesting rock in that it clearly displays a sort of shininess to it. This is the shiniest of all the rocks that we're going to look at today, and in fact this rock has a glassy texture. What's interesting about the rock, though, is that this is not obsidian. Even though, like obsidian, this rock has a glassy texture, you can see it's really, really shiny, almost metallic looking on some surfaces. This rock is an obsidian because it's a metamorphic rock. And the other main clue about this rock, other than the fact that it has a glassy texture, is it's very light, it has a low density, and also if I kind of rub the rock a little bit, if I rub it hard, you might be able to see there's a bit of a sooty residue on my fingers. So hopefully that'll be enough information to classify this rock. Okay, this next rock is M7. And let's see, if we look at different surfaces of this rock, it does not appear to exhibit any layering. So this rock doesn't possess stress-induced layering, but it is visibly grainy. In fact, so M7, let me turn over on this other side because the grains are kind of easier to see on this side. So I'm going to set the rock down and I'm going to zero in. Hopefully you can kind of see the rock there. So this is a grainy rock, and kind of like M8, this is a monomineralic rock, meaning there's only a single mineral in this entire rock, and the mineral in this case happens to be quartz. So this is a quartz-rich metamorphic rock that doesn't show any evidence of internal layering in the rock. And again, this is M7. Okay, next up is M5. This rock at first glance is pretty dark colored. And what's interesting about this rock is, depending on the specimen, a rock of this kind can either be foliated or non-foliated. Now this particular specimen, if I kind of turn over on the side of the specimen, you can pretty clearly see some layering in the rock. So I'll let you decide, based on this stress-induced layering, whether this is a foliated or a non-foliated metamorphic rock. It's pretty dark colored. Another hint about this rock is that most of the minerals in the rock are amphibole minerals. So again, this is M5, an amphibole-rich rock. And then here we have M6. This should be our last rock. A big hint about this rock, other than the fact that it doesn't really display stress-induced layering, a big hint about this rock is that it displays a sort of characteristic mottled green color. There's sort of mottles of white and especially green in the rock. And a form of this rock produces asbestos. Another hint about this rock is M6 happens to be the California state rock. So if you're really stuck on this rock, this sort of greenish rock that doesn't really show any evidence of stress-induced layering, just look up what the California state rock is, and that'll be this rock. Okay, well, I hope that gives you enough information that you can reasonably classify and describe the 10 rocks that we just looked at in this lab. Thanks very much.